Okay, I think we can start.
Thanks, Sean.
So, hi, good afternoon, everyone. So, welcome to BlockHash Live 2020 session, Consensus and the Consortia Know-House with Mr. Arun SM. So, I just want to let you know that this session is being recorded. Also, this session is conducted in collaboration with Hyperledger Kerala and Kochi communities. So I want to welcome our speaker today. Many of you might already know him. For those who don't know him, Mr. Arun SM, he's a senior software engineer, blockchain platforms at Walmart Labs. That is his day job, but he's a man who wears many hats. He's a Hyperledger TAC member and co-lead of Hyperledger India chapter. He's a maintainer of the Hyperledger Sawtooth project. He's also a co-organizer of Hyperledger Bangalore meetup group, etc., etc. So we are very happy to have him for this session. So I would like to welcome Arun on behalf of everyone here today. Over to you, Arun.
Thanks, Sean. And hello, everyone. Good afternoon. So, yeah, I would like to keep myself. It's simple. You could call me Arun, and then thanks for that quick introduction. I skipped this part then. So I'll quickly brief about what is going to be covered in today's session, right? So I kept the slides to be more simple to understand, and if required, we'll go in deep to understand what each of them mean. And feel free to notify me right any point in time. We'll then debate over those slides or those concepts and then understand how things work much deeper. um, so yeah, this content was prepared for to help both beginners as well as to those who already understand what consensus is to think differently when they design their application systems. So this is how we structure for the next 30 minutes. We'll understand what consensus is and why does it matter for blockchain. And we'll also understand what does consortium really mean and do we really need consensus in consortium and how is it handled. Then we'll go on debating on few of the points which we may come across when we design a blockchain solution, right? To understand, is consensus algorithm really playing a role in making a decision or not? So I'll leave with some open questions for you to go back and debate on those things. Um, so first, what is consensus? What does consensus algorithm really mean? So what do we understand by consensus, right? So in practical, in reality, we may see these kind of issues everywhere. Whenever there is a group, whenever there are um, a set of organizations or for any quorum for that matter, right? A small group of people, if they want to agree upon a particular topic, they follow some process. They all agree. They all start debating for and against a topic, and then they agree upon it. Or there could also be a process for agreeing upon a particular topic. For example, in our parliament elections, we do send our elected representatives, and then they go and debate in the parliament and make laws, which again we will follow, right? So that's a that's a process which they follow. And similarly, in any distributed systems, when we think about a distributed system, we need those machines to agree upon some data point. We want those machines to know what other machine is talking about, and that's where the consensus algorithm really play a role. And where do we see consensus algorithms in reality? You will find this, in fact, you are using this even now to be on this call, right? To provide high availability of the streaming service. Maybe the streaming service provider is using consensus algorithm behind the scenes running on their set of master nodes, and it's also being used in Kubernetes, which is widely used deployment platform. And then it's also used in, let's say, your cloud RDBMS database systems. It's used in clock synchronization, is used in load balancers. It's actually used everywhere. It's not something which is new only for blockchain. but this is a concept which is there in place for a while now. And what does consensus really mean in terms of distributed systems? What it means is we want our system to be available and we want our system to continue as expected, even if there are some failures. Let's look at what the failures really mean, which I was talking about, right? So in terms of availability, as I said, it's used in Kubernetes, it's used in load balancers. So consensus algorithms are widely adopted. And why do we use it in Kubernetes? We have set of master nodes. So these are the nodes which decide where a particular workload is going to be deployed on. And now when we have multiple people with equal powers, they all want to compete with each other, and then they all may end up with different decisions. And how do we know which decision to abide by? That's where Kubernetes follows HCD Raft as one of the consensus, right? So in simple terms, what we need to understand about a consensus is that we want our system to be available all the time. And when we say our system is available all the time, could be we are really talking in these true broader terminologies. We are talking in terms of a particular node crashing or going down randomly because of some reason which we don't know. And then other reason could be that we are really talking about a bad behavior in the network. It could be that particular machine is not able to handle particular floating point numbers, so it's not really intended errors which we expect in our result. Or it could be as vague as a particular node is really malicious and then they are trying to come up with a wrong response as they, or, I mean, in the consortia or in the network. So what we need to understand, we can classify these consensus processes into two categories. One, which we can put them under crash fault tolerant systems. So these are the algorithms or mechanisms which provides the solution to the first problem, the availability problem. As long as we have, depending on which algorithm we follow, as long as we have specified number of nodes up and running, we have our system available all the time. And when we talk about BFT, Byzantine fault tolerance, by the way, the term Byzantine comes from one of the Greek. So it's really interesting algorithm. It takes its own separate time to discuss what that Byzantine general problem is. I would suggest you to go and research more about it. And within that Byzantine fault tolerance, it could be intentional or unintentional behavior of an involved party. So now that we understand what consensus is, a quick recap of what blockchain is, right? To understand why are we even talking about consensus in a blockchain conference, right? So what is blockchain? Blockchain, I would put in it, I would put it in these three words. It's a distributed system, it's a decentralized system. It provides us immutable ledger of records. So at its core, any blockchain would some way or other, it provides these capabilities for us. Right? And in addition, of course, there are things such as smart contracts, which will help us in verifying if all the if if a if a certain rule which is set initially, they are met properly by all the participants when they send transactions. So I would not categorize. I mean, I did not catch them up in the slide. Rather, I just put them in this flow which you see on the screen. So in addition, of course, there are
Hello, Arun.
use this as a legal proof, and we can also stop some malicious behaviors if required beforehand. So these are the things which we generally do as in multiple blockchain platforms. They enable these capabilities through different means. Right? Ethereum could do it differently when compared to Hyperledger Fabric, and Sawtooth can do it differently from Besu. Each of them have their own mechanism of handling this or getting this done. Now that we know what blockchain is, and let's try to see what is consensus in blockchain really mean. So this, I know this has been a debated question for at least the beginners of blockchain technology, who think that consensus is, I mean, you might all have already been heard about mining in Bitcoin or mining in some other ecosystems like Ethereum. Right? So what is consensus in blockchain really mean? Is it just the mining? So if you see the slide, I put that crossbar on the miner person. Um, so that's supposed to be taken as it's not only mining through which we can achieve consensus in a network. So mining is in fact one of the way of achieving consensus. But when we think about enterprise blockchain applications, we really don't consider mining as one of the thing. Right? So what do we achieve with consensus in any blockchain network? We achieve in any blockchain network, we want those features, those capabilities which we just discussed in the previous slide to be enabled, and mechanism through which we provide those features or things is by creating the blocks. So where is consensus really involved in a blockchain? So in this slide, I'm giving you an impression that uh, consensus process is involved to create the block and to commit that block. Right? Um, so we'll come across few examples of how the creation and committing works across different blockchain networks and what options do we really have. But at a broad level, what we need is we need one person responsible in the network who everybody in the network agrees upon to create a block, and block has list of all the transactions. It has list of transactions which everybody agrees upon. That's a way of getting consensus. So let's say a client sends a transaction and then a node receives it, and then they don't know if the transaction is successful or it's should be accepted. What do we do with that? So that's where a smart contract would run, and then there is this whole process of consensus algorithm which runs, and it determines whether the transaction is valid or not, should it be considered as done or not. So everybody, so that everybody in the network, they are on the same page. um, yeah, let me move quickly to next page. So in coming slides, I'm going to discuss quickly about two other categories of consensus, achieving consensus. So earlier we saw that we could classify consensus as CFT and BFT, crash and Byzantine fault tolerance systems. Over here, I'm now going to discuss them a little different, in a little different manner. Nakamoto style consensus algorithms, and I can categorize the others section as fast finality based consensus algorithm. So what does Nakamoto style consensus algorithm really mean? So these are the systems which are proof based, right? So if any person in the network wants to create a block or wants to say that this particular transaction is valid, everybody should consider this transaction at this point in time. If you see, if you see a blockchain network, we really talk about blocks, and we also talk about position of the transaction in a chain, right? We so we need to know, we not exactly not only create a block, but we also put that particular transaction in one particular block in our chain. So that's a guarantee that anybody with that particular block with them, they agree to that transaction. It's not uh, that they skip that block, so one person can have the transaction in block one, other person can have that same transaction in block two. No, that is not how a consensus is achieved, because every transaction could change the state of the system underneath. And blockchain is, of course, a stateful set applications. Right? So within Nakamoto style, as I said, it involves some kind of proof to be produced so that they claim to be owners. And it's kind of passive consensus, or it's, I would put this as eventual consistency, which is achieved through Nakamoto style algorithms. What that means is there is a possibility that initially, even though a transaction is accepted, maybe that's the only node in the network which thinks that a transaction is successful. Maybe everybody else, they also think the same way with other transactions. And only when this subset, these two different subsets, they talk to each other, they come to know, okay, so other person did a better work than me, so the other person deserves to be a creator of the block. So that's why the proof is required. And coming across different proofs, there are proof of work, proof of stake, proof of elapsed time, and there are again a number of variants of it, right? Including proof of storage, proof of so there are even algorithms which would show, hey, this is how much compute power I have, kind of consensus algorithms. So key things to take away are being highlighted on the right side, such as these kind of algorithms are susceptible to 51% attack. Like if you are a majority holder in the network, then you get hold on to the network completely. These generally also come with uh, s- some limitations because of its eventual consistenciness. It is possible that the throughput or expected uh, number of transactions may not be agreed upon as quickly as we want them to be agreed upon. And the other category I was talking about, can be categorized or put them under fast finality algorithms. And what does this mean? This means we want an immediate result on a particular block. We want to know if a block is accepted by everybody or not immediately, right away, at that moment in time. And again, there are multiple algorithms in this section. I just highlighted two of them for quick reference. Um, so, like for example, in PBFT, it follows a step-by-step approach where at each step, for example, it starts with prepare, and then commit and those transitions, and then there are views involved. So what that means is, um, let's say you have a time slotted um, work hours, right? So a node, imagine that node is a worker and node has time slots. And let's say a node wants to work in a particular block for 5 hours. So let's say the node members agree for it, then yes, that particular node becomes leader for that view, that that term you could consider it. And in that term, again, it's not that the node which has won the election has complete authority. It could be implemented in a way that even though the proposer is sending transactions which are to be added to the block, others in the network, they do have a say whether to agree for that transaction or not to agree. So that's how the malicious behavior can be caught, right? And that's there's a requirement that we need at least 2/3 of the network to be up in PBFT consensus. And of course, Raft is a well-known algorithm which is also used in multiple other distributed systems, as I said in initial slides. And now that we understand consensus algorithms to some extent, let's understand what consortium is. So, so this is the definition which we can find on the internet. But what consortium means is really a group of members trying to do something to achieve a known result. Why does it matter for a blockchain project or blockchain solution? So when we think about blockchain, we are talking about multiple organizations coming together and helping to build something which will help each of those organizations indeed. And when we have multiple organizations, there will be multiple things to be there will be multiple things which are needed to be taken care, such as those organizations need a legal framework around when to call for a transaction or not, or you didn't just need a governance structure, right, to know who else they should agree upon to join that network of those initial nodes. They may also request for a way to know what kind of transactions that can be submitted. In terms, but they may not necessarily go hand in hand. For example, we may have a Nakamoto style consensus algorithm which provides both CFT and BFT behavior. And there are fast finality based consensus algorithms. One of them could provide CFT, other could provide BFT. Right? For example, RAF provides crash fault tolerance, and then PBFT provides BFT behavior. How do we choose what's the right balance between these? And isn't there a solution which maps to most of the needs? Hey, I want to catch malicious behaviors in my network. I want to stop my system from crashing. So is there a balance between that? So, unfortunately, the answer for this question is not as straightforward as we can come up with the problem statement, but rather let's try to understand a different approach to consensus. I would bring up a topic from Hyperledger Fabric to discuss this this phenomena. So it may not often be that we, we follow one of the consensus which is available over there, or we come up with our own consensus approach, and we decide how to create a block in a blockchain network. No, it may not always be that case. For example, in Hyperledger Fabric, the consensus is a multi-stage process, right? Where a client sends a transaction, gets all the endorsements, and then those endorsements are then sent to ordering service. The ordering service has responsibility of ordering them, and the endorsing organization and ordering organization, they may not be the same. And you can have any kind of consensus running on the ordering service clusters. And their responsibility is to know which transaction will go into which block, and depending on the endorsements which they have received. So if you really see where exactly do we use Raft and Fabric, we are using them at we are using that algorithm at the ordering service layer. Does it mean that um, that's the only place where the consensus is being achieved in a blockchain? No, because as I said, the actual parties are getting into agreement through their endorsements to the transaction. That happens much before a transaction is sent to ordering service cluster. So when we go for enterprise applications, we may end up seeing much more complicated, much more multi-stage consensus approaches. It may not be just straightforward as we initially discussed in concepts. Having discussed a particular scenario from Hyperledger Fabric, what other things are available within Hyperledger umbrella? So different projects, in fact, have different algorithm supports. You can find POET, Draft, PBFT, RBFT, MIR-BFT, and of course, so many of these frameworks within Hyperledger umbrella, they do provide option wherein which you can go and create your own new consensus algorithms. They provide pluggable interfaces. You define the process. You define when should a block be accepted by everyone. You define what should be done when a block is accepted. You define when should a transaction has to be accepted. So they provide interfaces for you, and you can implement your own algorithm through those exposed interfaces as well. So having dealt with these things now, what kind of questions do we really need to answer when we need to choose consensus, or does it even matter when we go for a consortium work? Yes, it does. As long as we answer these following questions, or maybe the questions I put up here are more simplified, and depending on the use case, you may have some additional questions into these, but you will need to look into multiple aspects, right? You need to check, hey, is this particular consensus approach providing me privacy, which is expected by, let's say, uh, this particular law requirement, the California Act, or maybe the European Privacy Act, or maybe Indian Privacy Act, which is being defined. Can I adjust? I mean, can I approve, or can I pass through that legal process with this approach? Can I, and what will be size of my network? If the size is big, then the fast finality algorithms, they may take a toll on the network, right? Reason is, again, being um, in a larger network, in fast finality based algorithms, we generally tend to have a fully connected network. And as we know, number of connections in the network, it grows exponentially. Um, so yeah, that's another reason, which another thing which we need to be wary about, the size of the network and the choice of consensus. But if we go for multi-stage consensus approaches, again, yes, it provides us some flexibility over there, um, in the sense that I can choose a part of, like, only in case of Fabric, uh, only the participants in a channel, they get involved in the endorsing policy process. And when it comes to ordering service, I can choose, with latest release of Fabric, I can choose part of ordering service cluster nodes, which have responsibility of creating the block. So those kind of features are available. And another question which we may need to discuss more in deeper before we make a choice is, of course, the degree of decentralization. Do I want complete decentralization where every party has equal right to do what they want to do in the network? Or is the model where somebody else ordering the transaction, or as long as I endorse the transaction, which is supposed to go in there, it is fine with me? Is that kind of thing sufficient? And also, it's like the speed of execution, all those factors do come in that. And finally, like, the performance and throughput factor, right? um, so some of these consensus algorithm, they may sometimes get limited because of just the sheer number of messages exchanged in the network. And the nodes, they tend to limit themselves at, maybe because of network limitations, maybe their compute resource limitations. That's another thing which we may need to think about before we make a choice. um, we have last 2 minutes. I'll want to ask, is it fine to extend, or do I need to end in next 2 minutes?
I think if you have time, then we can extend it for how much long would you think?
Okay, I'll probably skip I wanted to briefly talk about the smart contract, and then the deterministic nature which we expect in the smart contracts, so
Yeah,
that
yeah, sure, sure.
consensus.
I think we can extend.
Okay, so quickly I'll brief that up, right? Instead of spending more time on it. So another thing which plays very critical role in achieving consensus, or maybe avoiding. So most of these consensus algorithm, they may not be sus, uh, like coming out of the box providing solution to each of the problems. So far I have been discussing the problems with distributed networks, which are more towards agreeing upon something kind of questions, right? But there are other questions, such as uh, how do I solve the network security related aspects in my network? Is consensus really related to that? Do I need to worry I mean, about my security when I make a decision of consensus algorithm? Those are the other questions which would also come up. So there are possibility of denial of service attacks in uh, in consensus algorithms, which are like, for example, PBFT is susceptible to that. So, so one way, I mean, there are mechanisms, again, through which we can limit those kind of attacks. So make sure that you're, I mean, these are the simple checks, right? So I'll quickly talk about the smart contracts and this, and the need for determinism in the smart contract. Your smart, as long as you keep your smart contracts deterministic in nature, as long as you know that what is the expected outcome from your smart contract, no matter when it is executed or what time it is executed, you should get the same result. So that rules out that no node is giving you intentionally, I mean, no, yeah, the wrong result, right? And then there are mechanisms through which you can store the complete smart contract on chain, and you can have the governing related settings or governing related um, network governance related operations to be performed through on-chain operations, which means you are getting all the features which blockchain provide, the immutability, the decentralization, the distributed behavior for managing the network itself. Um, and since because of limitation in the time, probably go to I'll probably stop that discussion at that point. And so that's how we these are the kind of questions which come to us when we need to decide upon on a consensus algorithm. And thank you for your time today. I'm not sure if we have time for Q&A.
Yeah, yeah, we can have questions.
I'll open up for questions from audience.
If you can, either you can put it in the chat or you can unmute yourself and ask the question. Okay, let me ask one question myself. So I don't. So I want to ask about the consortium concept of how question. Oh, okay, so I think we already have a question. What is 51 attack? Uh,
Right. So let's consider a network where you have a proof of work. Let's say you have a Nakamoto style consensus algorithm, right? Where, as I said, they really work in a phase where they do eventual consistency as part of their agreement process. What that means is, let's say if you have 10 nodes in the network and you come up with a block or you come up with a particular order of transactions, and then you say, hey, this is the order in which transactions are to be accepted. What if remaining participants on your network they don't agree upon? Then it's just that you are thinking the transaction should be ordered in particular manner, but remaining parties in the consortium they don't think it that way. So with 51% um, um, participants on the network agreeing upon your block or be agreeing upon your ordering sequence of ordering, you can be very sure that majority of the nodes in the network they agreed for you. So that leaves behind the small portion which is minority to also follow up with the majority. So 51% attack means you falsifying node identity by yourself, or it's also called Sybil attack. Is also one of those. It also falls under that category, right? So you falsifying identities and then you claiming to be having more number of nodes in a network, and then you voting for yourself. So that's like you have control of majority of the network, and then you are saying, hey, you are producing the block in that majority, so that's why it should be accepted by everyone. That's what the 51% attack means.
so we have another question. Where does
Sure,
whether fast finality comes under CFT or PFT?
sure. So fast finality can be achieved. So as I said, these so they don't go hand in hand, right? In one of the slide I showed you the four directions. So they not necessarily go hand in hand. For example, Raft provides CFT behavior, whereas PBFT provides BFT behavior in your network, and they both are fast finality based algorithms. So why is Raft only CFT? Because once a leader is elected, then that leader stays on to be the leader for as long as the majority of the nodes in the network agree for that leader, uh, agree for that the leader is up and running fine. These are the CFT algorithms. Majorly, they are used for high availability systems in cases where you want uh, your network to be always up, the load balancers, right? And they run a cluster within themselves to know which service is available Even if one node goes down, then the other node takes that responsibility of identifying where to redirect the requests to. In Kubernetes, as I said, the master nodes, they run the raft again. So that is used to determine which node should get the uh, submitted workloads to run. And also it does many other things. I'm just oversimplifying the things which master node does in Kubernetes. Currently, is there an implementation for BFT in Hyperledger Fabric? So I may not know the latest state on that, but there were talks on providing BFT behavior, um, if not directly through PBFT kind. So as I said, in Fabric, the consensus process is a multi-stage process, right? It's not straightforward as you go and say, hey, I want this algorithm or that, I want other. It's not that how Fabric works. You need endorsements from participating organizations, and those endorsements are sent to ordering service for ordering the transactions. So it's a multi-stage process. You are in fact getting agreement from all the participants beforehand, um, and then going to ordering service. So ordering service at max can only put them one after other. And again, over there are possibilities of providing BFT behavior. If may not be through PBFT, which is not. I'm not sure if it is already implemented or not available. Sorry for that. But there are projects within Hyperledger Labs which work towards providing BFT behavior in Fabric. You may look into private chain code project that's in Hyperledger Labs that provides that behavior. How can identity? How can we identify the false identity in the network? So that's a good question, right? So multiple blockchain networks, they provide multiple ways of identifying if identity is not belonging to them. If you think of it, it's the same concept of CAs. Let's go back in time and understand how CA works, right? So what is CA? CA, I mean, I'm talking with respect to Fabric, of course. I'll then give you another example on Sawtooth as well. Fabric follows the identities, and those identities are permissioned in the sense you can configure your network to know, I mean, tell the network, hey, if a person comes to you and submits a transaction, or if a new node comes and joins your network, you should accept them only if they have this certificate issued by this party. So the delegation of proof goes to the CA. As long as your identity is issued by the CA, and then your network is configured to accept your I mean, to trust your CA, that's how the trust is achieved in Fabric. Whereas in Sawtooth, they go by a pure model of public key cryptography. You have your private key, which is your private information. Then you have a public key associated with it. You permission yourself in the network such that you put all the public keys on chain. You store your public keys on the blockchain network, and you tell, hey, here are the public keys. If somebody signs a transaction, signing involves, of course, using your private key, and it tells who signed or who submitted the transaction. Then you are telling the network, hey, if somebody signs the transaction using, I mean, and you can verify the signature using these public keys, then they are the valid people to be in the network. Again, you can do validator level permissioning, you can do transaction level permissioning, you can do smart contract level permissioning. Within the smart contract, you can do again check by yourself if a public key is what you expect for from the sender. So this is how we can identify false identity in the network. I think I may have used a wrong word when I spoke about Sybil attack. So Sybil attack is not necessarily always with the false identity. Sybil attack could also be with multiple identities which are valid, which everybody trusts in the network. Multiple identities, but behind the scene, they all belong to the same group of people or same person. I think there is one more question. Can we receive documentation in this context? BFT. So yes, sure. So I'll do one thing. I'll share across this documentation. I guess the video recording will also be placed on some days,
Yeah,
maybe on
yeah.
YouTube?
I think we can share it on the meetup groups as well as on the KBA forums.
Sure, Shan.
Yeah.
I'll send you the slide deck.
Okay.
These are good questions, by the way.
So I don't think we have any more questions. Uh, let me see. So does anyone have any questions? So I just want to ask one question. It's
Sure,
not really a technical one, maybe a philosophical one. If
sure. Okay.
you want to answer. So the consortium concept. Unlike a public network where you have rules but doesn't really have a governance layer, or let's call it a consensus, a social consensus layer below it, similar to a consortium. So does a consortium have kind of similar problems when it comes to scale, similar to the consensus and the actual consensus algorithms? Maybe not similar ones, but something different. Like you have consortium which scales up to maybe 100 people or 100 members, and
So it's a interesting question. The reason I would say that is because when we say consortium is growing, the group of organizations coming together and building a solution is growing. It may not necessarily translate to a physical infrastructure of compute resources growing in the same ratio. It could still be that we still have a limited number of participants willing to physically lend their compute resources, be part of the solution, and burning question as such. At least the one which I haven't come across in any use case or any examples, which
just one thing, like I was asking this question because you are in Hyperledger TAC,
Mhm.
so the more question was more really about coming to some consensus on the decision, like on the governance layer, like because consortiums mostly deal with, I mean, other than the infrastructure part or the technical part, you have to deal with a lot of things that people have to agree on, right?
Mhm.
Does does that have any problem when it comes to scale? Have you come across?
So, I mean, if you're asking the TSC decisions,
Not specifically TAC, but I was just asking, like, does consortiums have that kind of a problem when you want to scale it to more people, or not more people, but more organizations?
so okay. Um, so generally, I have seen consortiums where they form a group of. So there will be like, for example, I'll take Hyperledger itself as one of the thing, right? So within Hyperledger, they have a governing board where participants from different organizations they come together and then they run the organization, or that they run the Hyperledger project. Um, so again, there are places within that governing board which will be elected via election process. So the core set of group or this governing board, with if you consider Hyperledger itself as one big consortium which involves so many organizations, that core part of people, they make decisions on behalf of rest of them because they get elected to be in that uh, in that core set of groups. So you could, I mean, you could consider similar things happening in application or a solution space use cases as well. When even though consortium keeps growing, there would be a part of organizations through some mechanism they uh, tend to represent the bigger forum, and the decisions will be made through them, and that should still be um, handled in the same fashion as it used earlier.
Okay, basically, you build layers as you grow the
Yes. Yeah.
numbers. Okay, okay. think we have one question. What should be the size of ordering service cluster in Hyperledger Fabric? I don't know if you are.
So sure, I think I will not speak only for Fabric, but I'll speak generally for Raft. I think for now the majority adoption of Fabric is happening on Raft as a consensus algorithm for ordering service cluster. And for Raft to work, as it it requires at least 3 nodes to be present in the network. But the more the more the participants, the better it is. Have at least three. Having at least three is more susceptible to the failure attacks, where even if one node goes down, then you fall short of the quorum who can vote and get a new leader in the network. So having four is ideal in that case, because even if one node goes down, you still have three people, and out of four, to elect a leader you still need 3 votes, right? And um, so that's a possibility. You still tend to get a leader, but anything greater than that is what is a good behavior or good network configuration. But again, we need to keep an eye on the total size of ordering service clusters, because if we grow it to a larger size, like more than 10 or 15, then there is possibility of, because of that, in the connection from each node to each other node, which is a fully connected network, it tends to be more slower. What can we use the concept of consensus within an organization between departments? Can you explain your question more, Jinsha?
For example, sir, if you are considering an college, and if I am doing some blockchain network inside the college, can we do any consensus between the departments like that? That is what I am asking.
Sure. So, I mean, if departments are competing to do something with each other, like for example, each department has a choice of who gets to represent the college in some event, and they can run a consensus and get to choose a leader. I'm not able to correlate which exact use case I can give with respect to this college and department scenario, but you would require consensus when you have multiple parties and when they all try to do something, or you consider multiple parties having equal powers to do something. You need them to agree upon one common theme, one common thing. You could say, hey, let's do a meetup, or let's say let's do a hackathon, and everybody comes up with their own names, but you need a consensus on one particular name to be chosen for the event. So you could ask all the departments to come up with one name and then vote for each other. Whichever gets the highest vote, that could be a consensus of and that would be a way of achieving consensus. I'm not able to think of any other use case for college departments. So
Okay, thank you, sir.
come.
I think we can have a stop here. So we are over time, but for good reason. I guess we can stop here. So I just want to thank Arun for this wonderful session. So it was very informative and comprehensive based on the questions I can see. And do you want to say something, Arun?
No, I wanted to ask if recording is going to stop.
Can you say that again?
Oh, I see that session is still getting recorded.
Yeah. Session is still getting recorded. So thank you everyone for joining, and I just want to give a special thanks to Arun for taking his time on the middle of the day of a work day to come and speak with us. Thank you, Arun.
Thank you. It was my pleasure to speak here.
Thank you all, and so yeah, let me just stop the recording.